Good morning, everyone, and welcome to our Cloudsoft webinar, Learn how to build and migrate on AWS, plus the latest from AWS London Summit. So we've got two speakers with us today. We've got Steve Chambers, who is the COO at Cloudsoft, who's one of our panelists. So there's a bit of an introduction here. He's got over 20 years of experience working with innovative and market-leading companies such as Cloud, VMware, Cisco, VC, and Microsoft. He's held roles including programmer, consulting engineer, professional services delivery and development, technical pre-sales, technical marketing, chief technology officer, industry analyst, and consultancy organizations ranging from small startups to large multinationals. Next up, we've got Bryen, who is Senior Technical Evangelist at Amazon Web Services. He's also one of our panelists. He's passionate about emerging technologies and often speaks with developer communities around the world. As an AWS Evangelist, Stephen helps to increase awareness of AWS cloud services and to help customers understand the benefits that taking advantage of the cloud can deliver. He has many years of experience as well in designing and building highly scalable application and infrastructure architectures. Prior to joining AWS, he has worked with technical and leadership roles across various industries, including financial services, telco, and technology. So the agenda for this morning, we've got about an hour-long webinar. So we'll be starting with Steve's talk, which is building and migrating application on AWS. Next up, we'll have Bryen with his talk London Summit update plus what's new. And then we'll have a Q&A. We'll also have some time for questions after each talk. So save your questions. You can ask them in the chat panel from our platform this morning, and we'll be reading them out after each talk and making sure that we answer every question and that all your worries and all your doubts can be solved. And I'll now give it away to Steve to start his talk. Steve, it's all yours.
Thank you, Pauline. Thanks for the nice introduction, although hearing that replay back, I suddenly feel very old having done all those things. And welcome to everyone on the webinar today. What we wanted to do today was two things. One was really share what's going out in there, the realities of what folks are doing on AWS today. Who's building, what are they building, and how are they building? That's really what we want to talk about. Of course, it's a huge topic, so we pulled out the things that we see every time when we talk to customers and when we go to things like Amazon Summit and we hear from other people in the industry. And I'm really delighted Steve's been able to join us today to give us, some of the top takeaways from the Amazon Summit, which was yet another excellent event. So well done, Steve and team. In terms of what we're going to cover in this next section, which is about 20-25 minutes, we're going to go through how build and migrate are actually not two different things. There's a bit of a misconception that build is one thing, maybe for startups, and migrate is another thing, maybe for legacy enterprises. But the reality is quite surprising. Most companies have to use both of these in conference with each other to get things done. So we're going to talk about that. I'm going to dig a little bit deeper into migration, but we're really going to focus today on the aspects of build. So we're going to pull out a specific point on databases, although it's the same for many other Amazon services. In terms of databases, there's lots of different options. So how do you pick the right tool for the job? Then we're going to talk about some very hot topics. Microservices is one lots of people are interested in. Serverless is another one. Then how do you get things done? So we're going to talk about pipelines. We're going to have a very quick talk about DevOps, really about the metrics. And we're going to finish with well architected, because well architected is a framework, it's a tool, and it's something that Cloudsoft, as one of the few partners that can deliver this in the UK, can help bring all of this stuff that you're going to learn today in this webinar together to help you build and migrate on AWS. So the interesting thing with this slide is who's building on AWS. Perhaps the quicker answer is to say who's not building on AWS, because pretty much everyone is. I think the one report I saw was more than 90% of companies are building on the cloud. Amazon is way far and ahead the leader there, for good reason. It's most mature. I do love that statement from the CEO of AWS when he says there's no compression algorithm for experience. There's a reason Cloudsoft chose to work with Amazon primarily. It just works, right? It's got all the services you need in it. And when you look at the companies that are working with AWS, it's not just startups. There used to be a myth that Amazon's really just for startups and small companies. If you look at just some of the logos on here, these are huge worldwide complicated enterprises, and enterprises across many market segments. Where personally, we work with financial companies, oil and gas, hospitality, retail, agriculture, you name it, they're doing cloud on AWS. And in terms of what they're doing, that's an even bigger picture. If you were to look through the case studies on AWS, there are hundreds and hundreds of case studies, not just by segment and company size, but also by the actual solutions companies are doing. One that we commonly help customers with as an application-centered Amazon partner is getting business into the cloud with their web and mobile apps. We help companies deliver their software as SaaS. We help hospitality companies deliver their mobile guest applications to the industry. But it's also interesting to see that a lot of people are getting interested in the artificial intelligence and machine learning part of the cloud, big data, getting information out of data and gluing together that with things like sensors and IoT. And one good example of that is when you look at the oil and gas industry. Take one large company in oil and gas, and they're all pretty big. They're not just doing one thing in cloud, like they're not just deploying their web application. They're also putting hundreds of thousands of sensors on assets out there in the field in remote and hostile places. I think last week when I was in Aberdeen, it's the first time I've heard of something called bomb-proof Wi-Fi, which was quite an interesting phrase. But what they're doing with AWS is they're running those sensors from Amazon, they're collecting all the data into Amazon, and then they're using other Amazon services to make sense of that data. One really interesting story I've heard from a customer is when they're getting the data about sensors, they can start to understand things like vibration rates. From vibration rates, they can start to predict when a component's going to fail. And you can imagine that if an oil rig is going to stop pumping oil, if any asset's going to stop working, it's a serious impact on productivity. So you gluing together these Amazon services around data and apps is making a huge difference to businesses. And it's not that complicated to get started either. Sometimes when you look at these large companies and their complexity, you think, oh my God, how do I get going? Well, there's a great way to get going with AWS, which is using things called quick starts. There are lots and lots and lots of these, and just a quick search, you're bound to find something that is near your use case. The good thing about these is they tell you the problem they solve. They explain how they're solving it. They give you a nice diagram to understand the picture. But even better, they also have usually a link to something called CloudFormation, which when you click upon that, it will deploy that solution, that quick start solution inside your Amazon account. So a really quick way to kick the tires on use cases and building on AWS. So how do folks do this? I want to explode a myth, first of all, about two things really. One, that building on Amazon is just for startups. That's not true. We've seen that already. Lots of companies of different sizes and industries are doing it on many use cases. There was also a bit of a myth that it's all greenfield on AWS. It's only for the cool kids and the startups and the folks that don't have any legacy or complexity. Well, an interesting thing we found at Cloudsoft with working with startups is they do have some legacy. So they tend to have, for example, their application and data crammed on a single server in a colo somewhere, which needs to be migrated into the cloud and replatformed, and lots of other things. There's also the concept of a legacy mindset, which is often missed. A company that's got applications and data outside of the cloud might be the kind of bottom-up infrastructure focused. Like myself, I've been in the industry many years. I've been in cloud for 5 years, but when I first started using cloud, I thought of it in terms of virtual machines and virtual networks. So there's that kind of old mindset, which is also out there. But of course, large companies do have complex IT landscapes. They have applications that consist of lots of components, lots of layers and platforms and integrations. And so when it comes to migrating these into AWS, it's often not just one way of doing it. We often hear about rehosting, otherwise known as lift and shift. It's a way of just lifting data and applications and putting them in the cloud. It's kind of a low order way of doing migration because you're just copying bits over into AWS. You're treating AWS as a co-location. You're not really benefiting from all the extra value that Amazon's got. So at Cloudsoft, we tend to work on 3 other kinds of migration in the 6 R's, which are called replatform. So if you imagine you've got a database running in a virtual machine outside of AWS, instead of lifting and shifting that virtual machine into Amazon, why not use Amazon's RDS, the managed database, instead? I always joke that the best migration is no migration. So if you're using something like a CRM platform or email, then instead of lifting and shifting your email server, why don't you just repurchase that from somewhere? You could go, for example, to Amazon Marketplace and rent email and rent CRM from another provider and let them take care of all the cloud backend. In terms of moving code and data into the cloud, often it has to be refactored, and we're going to look at microservices and serverless in a moment. You can drop monolithic applications into AWS, but the chances are they're still not going to be exploiting all the benefits of Amazon if you do that. So there are lots of different options. And one key point here as well is that depending on the complexity of your application, you might use more than one migration method for the same app, because one app will consist of many different layers. I just mentioned CRM. If you think of an application that has, for example, sales and invoicing, you might choose to repurchase that layer into a SaaS provider. You might choose to re-platform your own state database into RDS, and you might choose to refactor your mobile code into a microservices system. So the reality is often different than what you might read some kind of abstract research online. Here's a way of describing that. Gartner have this great model called pace layers. And if you think at the bottom, it's things that don't change a lot. And at the top, it's the things that change all the time. So this is an example how you can map migration activities and methods to different pace layers. Always worth thinking about when you're looking at that. One size definitely does not fit all. So migration is one thing, and when you're thinking about replatforming, it's always an interesting point when we move folks who are outside of the cloud and they use one database to do many different things. So a classic is they use a relational database to do everything for an application. But it turns out relational databases are good for some things, but they're not so good for others. For example, a relational database would be good for matching your sales invoices and order system, but not so good for keeping the state of, like the game state of users in, you know, a million online game users. And often, you know, if you look at a game system, they've got both of those things. One, they need to track the gaming users, and they also need to be tracked who's paying what. So often they use more than one database. And in fact, you can imagine in one application, if you decouple components of an application, it is possible to see one application use more than one database. Another classic example is adding something like an in-memory database like Redis to improve performance, in addition to using RDS. And you can see there are 7 different database types from AWS. So using a mix and match combination to find the right tool for the job is a key part of both build and migrate. So picking the right tool for the jobs and thinking about decomposition of applications, I mean, this brings us nicely to microservices. A monolithic application is perhaps the most common architecture I've certainly seen in my long history in IT. If you imagine an application is deployed as one single executable, it's very common whether you're in client server or whether you're in mainframe or anything in between. There are pros and cons about monolith. It's common, right? There are lots of tools that are easy to build monoliths. It's seemingly simple because all the code's in one place, but it turns out the reality of doing this, there are reasons microservices came about. So for example, in a monolith, if you have a monolith where everything is represented as functions inside one executable, you want to change just one function, perhaps it seems easy just to edit that one function, redeploy the executable, and everything's pretty simple. But history is littered with issues with that, because often in a monolith, you're not 100% sure of what other functions inside a monolith are using the function you've just changed. So it's common to make one seemingly simple change and the whole monolith to not compile or to break when it's in production. It's also difficult to scale monoliths as well, whether they keep state, how do they scale out? So there are lots of challenges with monoliths, which is why microservices has evolved over the past few years. And you can see they've taken a monolith in this example and decomposed it into 6 individual functions, where each function, each microservice does one thing well. Now, the pros to doing this is that if you've got microservices, each one can be updated independently, which means your system keeps running while you're updating the download service. It also means you can scale out individual microservices as well. So if you're, for example, releasing the last Game of Thrones episode online and you're a TV service, maybe you want to really scale up your streaming service, but maybe after the reception Game of Thrones got, maybe you want to upscale your recommendations, because there's been a lot of chatter about that as well. The challenges with microservices is it is more complex. It's more complex in terms of things like observability. So if you imagine a single customer transaction having to traverse each of these microservices, and there's some problem with the end result of that service, it's returning an error to the customer, where do you know that error has been triggered in that system of services? That's why Amazon and others have come out with services like AWS X-Ray to increase the observability and transaction tracing through microservices. Also, there are things like cascading failures. I mean, the excellent team at Monzo, a fintech challenger bank, also runs an AWS. They've got some really top engineering talent. They had an outage recently. They wrote an excellent post-mortem, which I think is a brilliant thing for companies to do. And they explained how a cascading failure, first of all, they knew something was wrong, but they didn't know where the problem was. And it took them some serious engineering effort to find that. And that's just an example of, even with all the talent in the world, microservices can be a challenge. Often those individual services are composed with serverless functions. That's an emerging pattern. If you read about serverless, whether it's on Twitter, via blog posts from AWS, often it's thought that serverless is all about AWS Lambda. AWS Lambda is also something called functions as a service. So it's almost like the polar opposite of monolith. You can imagine if a monolith application had 10 functions in it. Well, in Lambda, if you were to translate that, you would have 10 different Lambda functions, and you would upload each function individually to separate Lambda services. So Lambda is really cool. It's also sometimes called event-driven. It's part of an event-driven architecture. But one of the myths is that serverless, which is really nicely described by this blog post from the excellent engineering team at Capital One, that sometimes people get hung up on the serverless, saying, well, it has to run on a server somewhere. Well, of course it does, but I wouldn't get hung up on the name. As it's clearly said here, it's serverless because you, as the application developer, don't have to worry about the underlying service. You don't have to reboot them, power them on, patch them, or anything like that. You just have to worry about the service that's running on top. It also means that the provider like AWS is taking care of scaling out. You don't have to worry about that. And the nice thing is, as you scale up, you pay more, but if you scale down, you pay less. So that's it's almost getting to transaction level cloud finance, which is really good. But serverless is not just about those functions as a service. It's not just about Lambda. This is a great picture to show that all the other, what I call higher order services from AWS, higher order because they're higher up the stack. If you look at RDS, you don't have to worry about servers. If you look at S3 storage, you're not having to worry about disks. All these things are hiding and abstracting away the infrastructure beneath you, and there's a huge benefit to using them to take away that whole server headache. Serverless is also not a silver bullet, so many applications are client-server architectures. Client-server architectures are simple, they've been around for years, but they also have challenges. They have challenges around state, they have challenges around scale, and it would be a fallacy to say, okay, well, if I put my client-server code into a serverless architecture, then it's going to be fixed. There are things you'll need to work on, like changing it into an event-driven architecture, for one. The third myth is really popular. People think serverless, and I've just explained, there's no servers, therefore there's no operations. There are still operations, they're just higher up the stack. So operations in terms of like RDS, you need to know about the database options and things to configure, when to set a maintenance window, things like that. But that's much easier than have to deal with all the low-level clustering and everything. There's also, thinking back to the microservices example, there's the observability. So it's a much higher level, more application-centered view of operations. And also, that lovely illusion on huge cloud providers like AWS, that scale is infinite. It's certainly massive, but there are a couple of things you always need to know, and about each individual service. Each Amazon service comes with soft and hard limits, so you need to know about those. Amazon are not just going to let you run away with capacity and then run off without paying the bill. There are some limits around it, but they're very flexible and easy to engage to get those changed, so on soft limits anyway. But they're also around things like Lambda, for example. There are things like cold starts and hot starts and various different things you should know about how those things perform and how they impact your scale. So for example, if you're using a serverless architecture and you know that you're deploying Game of Thrones this weekend and you know you're going to get incredible access on your platform, you certainly need to know about that scale so you don't get caught out and work with AWS. The one thing we enjoy the most, I think, at Cloudsoft, and I think I speak for all our engineers, is putting all of those things that we've talked about together and helping customers get whatever their product and service is into the hands of their customers as fast and reliably as possible. And one of the ways we do this is with continuous integration and the whole kind of DevOps approach. Cloudsoft's been doing software development in the cloud for 10 years now, so this is kind of bread and butter, and we do this every day for us. And it's a real joy to bring it to customers who haven't got this capability and bringing it to life for them. So there's the abstract view at the top. You know, for one thing, it's really helping developers reliably and quickly build, then test, then release their code. The way we bring this to life on AWS is there's a couple of interesting points here. One is it's not just about application source code. The real benefit here is if you start doing your cloud as code as well, or something that's called infrastructure as code. Amazon have their own language and service for this called CloudFormation. So in a developer's version control system, they can have in the same place all the configs and the code for their application, and at the same time, the whole definition for the cloud resources that the application needs to run. So you know that when you deploy this, those two things are completely in step, as opposed to the old world of the developer compiling source code, creating an artifact, and then a separate operations team building the cloud, and then hopefully putting those two together in production and seeing if they work, which invariably it wouldn't, and spend a lot of time, wasted time, trying to find out why. Some of the services we help customers get together, Amazon have their code commit, other people use GitHub and different versions. All of these things are integratable. A lot of the Amazon tools are free, which makes them very appealing. They've got systems like Code Deploy to send out your artifacts, pipeline to manage the system. You know, this really brings together the whole continuous integration pipeline on AWS. I think one point I'd make on this as well, the speed, quality, cost is, it does feel like at the moment, you know, I've been in this business over 2 decades, and it used to be the rule that you could either have fast, cheap, good, you've got to pick two. But it is at the moment, if you combine the Amazon cloud with something like DevOps, you've got an opportunity to be both fast, high quality, and cost optimized and low cost. So it's a really exciting time for the industry. Rather than gut feel, I mean, it's okay you're saying, you know, this works for us, it might not work for you. Metrics are everything, really. So this is a fantastic book from the team that brought you The State of DevOps, Nicole, Jez, and Jean. They really put a lot of proper research, PhD level maths into proving that this works. I'll just pick out, there are 4 metrics that we always ask customers to look at. One is how often are they deploying? How long does it take them to get the change from code into the customer's hands? When they need to restore, how fast is that? And how often do their changes fail? And you can see here that out of the research that these good folks did, there's a huge difference between high performers and low performers. And for our point, when we help customers build and migrate, essentially we're helping them move from the right to the left. The last point I'll make about bringing all that together, it's more than just DevOps, it's also thinking about the architecture. If you think about migrating applications into the cloud, or whether you're building them from scratch, or whether you're combining the two, which is most reality, AWS have this excellent framework which is built on, I don't know how many thousands of days of expertise from solutions architect and customers like Capital One, but it's a really good practice framework covering operations, security, reliability, performance, and cost. And this is not just for reviewing workloads in AWS and trying to work out how do I improve them. You can also apply this to workloads outside of AWS. You could look at something in Azure. You could look at something that's not on cloud at all. So you could look at something in colo or on premises. And you also don't have to use it for workloads that have been deployed. As I've mentioned, as we help customers look at build and migrate, we use this to try and work out what's the best way, what does that business need through this prism, so we can help them prioritize when we build and migrate so they get the best value out of AWS. And well architected is a real key tool for us for that. So quick takeaway, everyone's doing it and they're building all kinds of things. Build and migrate is a combination, they're not separate, discrete things. Replatform, refactor, repurchase are the key migration methods. Lots of different tools. Choosing the right one is often a challenge. Best thing about cloud is if you make a mistake, it's easy to change. Microservices can be great. Serverless can be great. One thing I haven't mentioned, which I thought I'd leave to last, is finding the good talent to do this is not trivial. And I have met CTOs that do struggle to find the right people, and in fact, sometimes choose not to do these things because they can't find the folks. So do be aware of that. And I think the combination of DevOps and well architected is a killer combo for bringing all of that to life. And I think with that, I will open for questions.
Thank you very much, Steve. So do we have any questions? So we've got one question. So Steve, do you see many people using containers?
I hear about containers a lot. So the three things I guess we talk about with containers is, so first of all, no is the first point. I do hear a lot of desire for containers. I think people are very much swayed by, I don't want to say Kool-Aid, that's a bit of a pejorative term, but you know, there's some great people in Google, there's Kubernetes from Google, and people think that's a great thing. And if you're an infrastructure focused person and you're familiar with virtual machines, then containers feels like the next natural thing to go to. Containers are quite different to virtual machines. You know, once you use them, the reality is often it's still hard, it's still infrastructure. Kubernetes is a difficult thing to use. So for me, you're still in the infrastructure. I always push people to use higher order services. My view is the less infrastructure, the less low-level management you have to do, the better. I've just seen over the past 4.5 years, the more higher order services people use, the more serverless stuff like RDS, like load balancers, things like that, and not containers is great. But I do realize that I think the people that ask the most about containers are hugely technical people who feel that containers give them things like the ability to run on any cloud. So that's one reason I've heard people say, hey, Steve, if I put my application in containers and I can run it on any cloud anywhere, yes, you could run that container on another cloud, but you often find, as I've said with build and migrate, that application probably relies on external systems like identity and access management, some kind of security layer. Data has gravity, so moving data between clouds becomes an expensive thing. So like anything, and I think that's what I tried to get across in this presentation, is the reality of doing these. It's messy out there, right? So that's what we work on. But I hear about containers more than I see them. We use containers in Cloudsoft as part of our builds. You know, we have very technical engineers, so they certainly have their place. They really speed up build times. As you're putting code through a pipeline, they're fantastic. So some huge benefits from using them, but you're still using infrastructure to some degree, I would say. I hope that answers the question.
Fantastic, thanks, Steve. And that was our one question. We've got more time at the end of the webinar for more questions anyway. So we'll just jump on to Stephen's talk now. Stephen, it's ready when you are.
Hello, everyone. Can you hear me? Good stuff. I think you can. I can see some green bars on my screen. Good stuff. So firstly, thanks to Cloudsoft for inviting me along to the webinar today. It's exciting to be here to talk about some updates from our most recent kind of London Summit event, and some also new announcements from AWS over the last few months that I think resonate with some of the message that Steve was sharing there. I'll try and give you some customer stories throughout the session so that you can kind of map what I'm saying to customers in the real world that are doing some of the things I'm talking about on AWS. But firstly, let's have a look at our London Summit update. So one step too far, there we go. So a few weeks ago, we ran a summit in London. This is an annual event that AWS run, and I would encourage you to look at attending future events if you were unable to make the event a few weeks ago. This is an actual photo of the event at the back of the slide here. We had over 14,000 attendees at the event and over 65 technical sessions. So a great opportunity for people to learn about AWS and meet our partners, but also get hands-on experience listening to customers and partners about how to use the AWS platform for their specific needs. In addition to that, we had a keynote presentation where we made a few announcements, some technical and some not so technical. So I just want to talk about some of those announcements for a second, and then we'll dive into some specific technical features that weren't necessarily announced at the summit, but I think will help you as you're thinking about how you build your applications in the cloud or how you migrate your applications to the cloud. First thing we announced was something called the AWS Get IT program, and this is something that I'm really passionate about. This is actually a program to get more girls to consider careers in technology. We know that there's a huge skills gap in technology, and we know that there's a huge diversity problem in technology. So the AWS Get IT program was formally launched at the London Summit a few weeks ago, and we have an aim to inspire over 13,000 students to get a career in technology. And we piloted this starting last year, and we actually went to hundreds of students across many schools, mostly looking at girls' schools, but many boys involved as well. And we also, what we do is we run a program with those students to teach them how to, how to come up with technology ideas and how to build an app in the cloud. So we give them the confidence to present their idea. We give them some ideation process training so they can learn how to create application ideas. And then at the London Summit, we actually had a grand final where we announced the winners of a competition. So each team comes up with an app idea, and then AWS will actually build the final app for the students. So some really inspiring to see these young people get excited about technology and careers in technology. We actually had the winners announced in London. They designed an app that would allow children in classrooms that were hard of hearing to do live transcription of the teacher from a microphone connected to the teacher's, lapel or something. So some really inspiring ideas coming from students, and we're going to go and build that app for that school now, and hopefully expand it into other schools as well. So if you're a woman in technology, or you'd like to mentor some students or some teachers that are doing this kind of stuff, we're looking for ambassadors in our customers that can help with this program, and I encourage you to reach out to us at AWS if you're interested. The other thing we had at the summit was we had a ton of customers on stage announcing their use of AWS in some quite interesting ways. So we had Sainsbury's on our keynote stage, and they were talking about how they have moved their groceries online business to AWS. Now, their groceries online business is a huge part of their business, as you can imagine. And through moving that to AWS, they announced that they had 70 to 80% performance improvements. But touching on what Steve said, they actually improved their release cadence to 4 to 5 releases per week, whereas previously they were releasing maybe once a quarter. And that's in the move from a monolith to microservices type approach, where they're able to release much more frequently and reduce the risk involved with deploying monolithic applications. They also announced their intent to do more machine learning and data science in the cloud. They are using AWS to do machine learning to predict the fastest routes for grocery deliveries to consumers. So they use machine learning in the AWS cloud to do that. And they're actually using serverless technologies to orchestrate a lot of the machine learning work in the cloud as well. So really big, 150-year-old company that are trying to transform their business through machine learning and provide a single customer view, so they can provide kind of personalized experiences through machine learning as well. We also had some, younger or more agile companies like Comic Relief. Comic Relief are a company that I care about a lot, because I actually worked with them about 10 years ago to build their infrastructure. And we were literally breaking our backs to rack blade servers in data centers in London Docklands, for about a 2 or 3 week period, racking servers, spinning up virtual machines, installing software. They had a large Oracle rack implementation, and over time they migrated that application or rebuilt that application, their donations platform, into a more modern application, which moved away from Oracle RAC onto MySQL. So they moved to open source alternatives. And they also introduced things like queuing and microservices, actually at the time using Cloud Foundry platform as a service to build their application. Now, at the summit, they announced the 3rd iteration of that project that they've gone through over the last year or so. They've actually completely in-housed their development of that their donations platform and migrated it all to AWS serverless. So they have over 90% cost savings from their infrastructure from running it in serverless. A real interesting use case for the cloud and specifically serverless technologies, where they're able to scale up the infrastructure on that one Red Nose Day event, and for the rest of the year they never pay for idle resources, which they were doing traditionally with their other implementations. So a great example of serverless technology, and there's some great blogs if you look around online that showcase that story from Comic Relief, which is really interesting from a technical perspective as well. And then we had a few other customers. Interestingly, the question there about containers, Ministry of Justice actually containerized 9 out of their 10 legacy Oracle applications, Oracle middleware applications, and moved them to the AWS cloud. One of them was unable to be containerized due to software restrictions, but they lifted and shifted that one to the cloud in a more of a rehost model. But they moved 9 of their 10 applications to containers, and this was for the legal aid service, which provides legal aid funding to people in the UK in need of legal support. So a real kind of critical business for them was migrated to the AWS cloud, and they were able to containerize their applications and improve the availability and resiliency of their applications in doing so. Another theme that we saw from the summit was that AI machine learning is really becoming the new normal. We have seen many customers interested in AI machine learning. Steve touched on it in his presentation. We heard from pretty much all of our customers in the keynote, and a lot of our breakout session customers were talking about how machine learning was changing the way their businesses operate and enabling them to engage better with their customers. And predictions show that worldwide GDP today is around $80 trillion, but by 2030 that will be about $112 trillion. And PwC predict that $15.7 trillion is going to be added to the global economy through productivity improvements through AI. So there's a huge interest in companies using AI machine learning to enhance capabilities and to drive digital transformations in their business. But one of the challenges that a lot of customers have with AI machine learning is that it seems like a very steep learning curve. It seems like a very hard kind of hurdle to get over to get started with machine learning. So what we've done at AWS is we've released some kind of technology and tools to help people get started with machine learning in the AWS cloud. We actually released this. This was last November. We announced this car called a Deep Racer, which is an 18th scale race car. So it's designed to, it basically learns through a type of machine learning called reinforcement learning to drive autonomously around a track. And you can use AWS tools in the cloud to train machine learning models and get started learning reinforcement learning without having to think of your own kind of use cases. You have a specific challenge that you're trying to solve here, and we have a ton of starter packs available for people to get started with reinforcement learning, specifically with Deep Racer. We thought that wasn't good enough. We thought we'd actually create a whole league of racing. So actually at the London Summit, we had 2 physical tracks where people can race Deep Racer cars and race for who has the most optimized algorithm to race these cars around the track. And the fastest times get free tickets to AWS reInvent in Las Vegas to enter our Deep Racer grand finale. But the cool thing is it doesn't stop there. If you miss the London Summit, you still have a chance to get involved. We have a simulator in the Deep Racer console. We just announced in the last few weeks online tournaments. So we now have the ability to do online racing, and the first online virtual tournament is called the London Loop. It's based on Silverstone racetrack. So we have an online loop that you can train the car to move around and really dip your toe in the water with machine learning in a fun and exciting way. And again, the winners of the virtual tournaments online, or the overall fastest times throughout these virtual tournaments that we run, will also get tickets to the grand finale in Las Vegas at AWS reInvent in December as well. So a really good way for people to get started, and a fun way dip their toe in the water with machine learning. So in terms of building and migrating applications, I wanted to talk about a few services that features that we've announced over the last few months. I just have 3 of them to touch on today. But one of them that I think was a really good announcement from AWS was something that we call the AWS Replatforming Assistant. So if you're running Microsoft SQL Server 2008 or above on premises or in a cloud somewhere or in the AWS cloud itself, we have this assistant now, which is basically a toolkit that enables you to inspect your database, understands the structure and schema of your database, anything around stores, procedures, those kind of things. And it exports that database from your Windows machine and imports it into SQL Server 2017 running on Ubuntu. So what this does is it allows people to remove the Windows licensing cost from running SQL Server in the cloud. So it allows you to re-platform your SQL Server databases away from Windows and onto Linux and save you significant costs from a Windows licensing perspective. So if that's something that if you're running Microsoft SQL Server today and you're running it on Windows and you have significant licensing costs, SQL Server now is supported across multiple platforms, including Ubuntu. So we're supporting doing that migration for you with the replatforming assistant. And if you want to learn more, there's a link here at the bottom of the screen. It should be quite easy to remember, just /SQL from the AWS website. Secondly, this was an announcement we made a few months back, but I think it's really important as you move from a server-full to serverless model, as you move from monolith to microservices. We added support to our application load balancer for direct triggering of Lambda functions. So our application load balancer is a layer 7 load balancer. It allows you to do things like host-based routing and path-based routing. So you can route specific traffic from your application users to different endpoints. So the great thing about this is you can put it in front of your monolithic application, and you can use this feature to start taking certain microservices out of your monolithic application and moving them into Lambda functions. So you can start to move from serverful to serverless, and over time you can gradually migrate, migrate or convert your application from monolith to microservices using serverless technologies. So really simple, easy way to just abstract your application without having to think about moving the whole thing at once. You can start to move piece by piece by just moving certain paths or certain APIs to serverless functions on the back end. The other announcement I thought was really interesting over the last month or so is traditionally in AWS, you've been required to notify AWS when you're doing penetration testing of your applications in the AWS cloud. Now, this was important for us because we didn't want to block that traffic for our customers because you were doing a pen test. We wanted to be aware of that so that we could, adjust our threshold so that you still were able to complete your tests on time. Now, obviously, over years and years of running in the AWS cloud and lots of experience of customers running these penetration tests, we're able to use this data now to remove the requirement for you to actually need to give us prior notice for doing penetration testing for 8 of our core services that are listed here at the bottom of the slide. So what that means is that if you're doing a more DevOps model, if you're doing continuous deployment and continuous delivery, and you're trying to integrate continuous security testing into the way that you're doing that, there's no longer a requirement to slow down that process through raising a request to AWS to do penetration testing. You're able to go ahead and do your penetration testing without letting us know, and we now, in the background, we're now able to, make sure that we're not blocking those and identifying that they're penetration tests and not kind of real attacks on your application that we should be blocking for you through our edge services. So a nice feature there to speed up your development, specifically if you're integrating continuous testing or vulnerability or penetration testing into your DevOps workflow. So lots of new announcements from AWS coming all the time. I'd encourage you to check out aws.amazon.com/new, which is where we announce kind of our what's new page of what's coming from AWS on a regular basis. Last year alone, we launched nearly 2,000 major features and services. So lots of change happening. We've just picked on a few of them today. But the real good thing to know is that this change is all for good, and we're not implementing changes that are not backwards compatible. So you typically get benefits of these features immediately as soon as we announce them. So hopefully some insight there into some features that are new from AWS that are aligned to what you're trying to achieve with your business's technology strategy. So I just leave you with the thought of kind of what will you build next in the AWS cloud. And thank you for your time.
Thank you very much, Stephen. That was fantastic. Have we got any questions regarding this very interesting talk? No questions, it seems. Lovely. That doesn't mean that you can't ask questions later. We've got different ways of getting in touch with us. You can email us at ask@cloudsoft.io. We've also got Cloudsoft also offer well-architected reviews in case you've been inspired by these talks to review your AWS environment. So we can do that for you and with you. You can either click on the link here or get in touch with us again with that same email address. It's ask@cloudsoft.io. And that's all for us today. Thank you so much for attending. Have a lovely Tuesday. Bye.